So we are in section 15.7, which is cylindrical coordinates. Cylindrical coordinates is nothing but the polar coordinates in space. You know, polar coordinates are theta instead of x, y. In 3D. We know r of theta instead of x, y. We know the relations of r and theta instead of x, y. You know that very much. We studied it many times, and I sent you some problems and solved examples to work and practice. R equals root x squared plus y squared, and tan theta is y over x. The other way is, if you know r and theta, you can change it into x and y the way we usually do. X is r cosine theta. And y is r sine theta. This is in 2D. 2D polar coordinates. In space, we call it cylindrical coordinates because we have r, theta, and z. Z is the same. Z in polar coordinates is the same Z in Cartesian coordinates, Cartesian or rectangular coordinates, x, y, and z. So this z is the same, and we'll change our x, y with r and theta. Why we do that? Because some problems cannot be solved with in x and y. It needs to be changed into polar, as usually we have the situation in 2D in double integral. We have the same situation and same problem in 3D and more. Some regions are suitable for cylindrical coordinates. Why we call it cylindrical? Because this is easy. Because r equals 2 means what? Root x squared plus y squared equals 2. This is equivalent to x squared plus y squared equals 2 squared. It is circle in xy plane, circle in 2D. But as you know, this is not a circle in 3D, but change color. So this is a cylinder in 3D. Circular cylinder. Yes, it's a circle in 2D. So it's a circular cylinder in 3D. Exactly, you can say a circular cylinder in 3D. The same circle is the base in XY plane, but it's a cylinder whose axis is parallel to the Z axis. A circular cylinder in 3D with Z axis as the axis of the cylinder. You know how to draw that? Very easy. This is the 3 axes. We write here x, y, and z. So this circle is in 2D, it's a circle. So this is x square plus y square equals 4, or simply look at the equation. It's very simple in polar coordinates. Now in cylindrical coordinates, r equals 2. That's it. Very, very simple equation. In 3D, if you look at x square plus y square equals 4, in 3D, it's not a circle, it's a circular cylinder. So this is the cylinder. It's infinite cylinder, having this circle as its one of its cross sections, and you can see this circle everywhere when you cut this cylinder horizontally. When you cut this cylinder horizontally, you cut it at a circle, the same circle with the same radius parallel to the x square equal plus y square equals 4, we already know. So why we call this cylindrical coordinates? Because this simple equation r equals 2 represents a circle, a cylinder in space. That's it. So is a cylinder. To understand it, it's nothing but polar coordinates in 3D. As the same way we need to change x and y into r and theta, because we deal with a disk or circular rings and this stuff, and or even the integral cannot be done in x and y, we need to change it into r and theta. We have the same situation here in 3D. That's it. So let's begin with some example. Evaluate this triple integral over this region Q. This integral is exponential of x squared plus y squared dv. So we have now triple integral, and this is the element of volume. And what is the region E, or the solid Q? It will be explained. Q is the solid bounded by the cylinder x squared plus y squared equals 9. The xy plane. So it is not the infinite cylinder, of course. We have to deal with finite solid, bounded solid, xy plane, and the plane z equals 5. So another horizontal plane. So what we have here, maybe this part, maybe this part of the cylinder. This is what we have. So let's make some. The circle is not 4, or it was not with radius 2, it's with radius 9, because this is the radius square, this 9 is the radius square. So it's 3 square, the r equals 3. So we call this is 9. So this is the region Q we are integrating over. X squared plus 9 y squared equals 9. And here the plane, this is the plane, z equals 5. It will cut the circular cylinder because it's a horizontal plane parallel to the horizontal base or circular base. It will cut it into a circle. X squared plus y squared equals 9. But what is the difference between these two circles? x squared plus y squared equals 9, and z equals 5. What is different here? Z equals 0 in the xy plane. So this is the region we are integrating over. As you see here, we cannot, in fact, we cannot perform this integration at all because it's e to the x squared. We cannot do it with respect to x or with respect to y because we cannot do it. It's not an elementary function. So we write this remark. Integral of e to the x squared dx is not elementary function. Means one cannot integrate it. We cannot perform this integral.
دكتور أنا عندي سؤال.
Oh, okay, go on, Shahab.
Why can we not integrate?
It has another proof that it cannot be done in elementary. We can approximate it. We can represent it by infinite series. Other methods is not. This is the meaning of not an elementary function. No function we know of the functions we know can give the solution of or the result of this integral.
Okay.
If it is e to the x, a to the x, if you have the derivative of the exponent x squared, it's okay. But this way cannot be done. And many other integrals we met before. For example, sine x over x and the others. Do you have any idea to perform this integral?
For e power x squared or e power x?
Yes, e power x squared.
I'm not sure.
Okay, so try the methods you studied. I made some revision of integration and sent it for you.
I think substitution.
Okay, no substitution will help. No idea will help here. In fact, there is a proof that it is not an elementary function at all. So one of the important integrals. So don't try, please. Don't waste your time in it. Now, what we have is not this, but we have x squared plus y squared, and this can be changed into r squared if you use the polar coordinates or the new name for it in 3D, the cylindrical coordinates. So first part of this integral is to read this region as a type 1 region in space from z equals 0, here z equals 0, here up to z equals 5. So the integral is this is the solid cube e to the x squared plus y squared dv. dv, you know, dz, dA, dz is the first, and A is the region, the projection of this solid in space. So we change it into, R. Here, e to the x squared plus y squared dz dA. The first part is easy because there is no z here. And what is r? As you know, I mentioned, r is the projection of this solid in xy plane. We are familiar with this now. We integrate for z first from z equals 0 up to z equals 5. And A is the projection of this solid on the xy plane, which is the circle you see r square, sorry, x square plus y square equals 9, or r equals 3. This is easy. The first part is very easy because there is no z here. So this can be considered as a constant. It comes here and integrate the z and substitute to get 5. This is easy and the 5 is out. So we come to a double integral of e to the x square plus y square dA over this region. This is the region R. This is the
معلش
disk.
يا دكتور
The disk R.
معلش يا دكتور ممكن بس نعيد الحتة دي ثاني
Which part?
اللي هو ازاي اللي هو الستيلت انتجرال ده اتشال ان ازاي اتعملنا الخمسة وحطيناها بره.
Okay, Assam. This is e to the x square plus y square. There is no z here. So the dv is dz, dx, dy, or dz, dy, dx. I begin with z. I begin with z here.
Okay.
As usual for triple integral, fixing x and y and moving here from the smallest z up to the biggest z. The smallest z here is z equals 0.
0. Okay.
And here z equals 1.
مش 5.
مش 5.
Sorry, 5. Yes,
5.
yes, sure.
Okay.
Z equals 5 here in this plane. So integrating this function, it's a constant function with respect to z, and moving from the smallest z, which is z equals 0, up to z equals 5, then integrating the result with respect to x and y, or the area element in the xy plane later in the coming step. So this is, Assam?
Yes, okay, doctor.
This is constant with respect to z, comes out, and then z is z from 0 to 5 is 5. This is easy. And the 5 is a constant to be taken out. Now we are faced with double integral as usual over this region, which is the disk x squared plus y squared less than or equal to 9. As I said, we are faced with this integral before. We cannot perform this integral unless we have some trick. The trick is to use polar coordinates. So this is dx, dy, or dy dx, same, it will not help. So the idea is to solve this into polar, change into polar coordinates, or theta. So we can say this simply from the beginning. We use cylindrical coordinates, r, theta, and z. Z is the same, but r theta instead of x, y. So what will happen? How this will help, Assam? X square plus y square will be r square. And dA, as you know, dA in polar,
it's r
yes,
dr d theta.
Yes, exactly. This will make the thing. And we have this polar strip, fix theta. This is the polar strip. Fix theta and vary r from inside to outside from the smallest this way. Here r is 0. Here r is what? R here at the end is what is the equation of r on this circle? It's r equal 3. On the cardioid or other complicated curves, it's function of theta, not constant function. So r will be from 0 to 3, and theta will move. But then scan the whole region, this disk, by this polar strip. fixed theta at the end. R will vary from 0 to 3. Theta will vary from 0 to 2 pi to scan the whole region. Then scan the disk by theta from 0 to 2 pi. So the integral is q e to the x squared plus y squared dv becomes now what? 5 over r e to the x squared plus y squared dA. How we change it? We use this transformation. This transformation will make it easier. How this? So it's e to the r squared, and dA will be r dr d theta. This is very important. This is the dA in polar. Same. What is the bounds of r? R from 0 to 3, theta from 0 to 2 pi. That's it. So now we have very simple integral. We can do it because the bounds are fixed numbers now. So this is what we call polar rectangle. What is polar rectangle? R from 0 to 3, theta from 0 to 2 pi. In this situation, we can make some simplification. We can do it as integral of the function of theta times the integral of the function of r, because they are product of separable functions. This is d theta from 0 to 2 pi times this, the other integral, r squared times r dr. Note carefully, Shahab, what happens. Why now this is solvable. We still have e to the r squared, similar to e to the x squared or y squared, but the situation is different because we got this derivative here. The derivative of the power or the exponent here is appeared beside dr. This is the derivative of r squared. Now we can use substitution, Shahab. Okay?
Okay, تمام.
Okay. So this, if you consider this u, then this is du, but we need to put 2 here to make it the exact derivative. So let's have u equals r squared. So du equals 2r dr. So we need 2 here. So I is 5. And the integral of d theta is theta from 0 to 2 pi. We get 2 pi. This is easy, and we can put it directly here. We need half and e to the r squared 2r dr. Why is that? Because we need the derivative. Think of this as u, and this is du. And r from 0 to 3. We can cancel these 2 and go on. 5 pi. Then this is, think of this as e to the u du. What is e to the u du? Exactly e to the u. So what we get? E to the r squared from r equals 0 to 3. Substitute for the r now for the upper bound. First, then plug in minus, plug in the lower bound to get 5 pi e to the 9 minus e to the 0. So it's 5 pi e to the 9 minus 1. This approximately equals 1.27 10 to the 5 using calculator and approximation. 10 to the 5. Okay. if this is needed in decimal notation, but this is enough. This exact result is enough. Any question? Is it clear now, Assam? No, Assam? Sama? Catherine?
clear يا دكتور.
Okay.
انا برضو
So-
كده. بس في حاجة بس مغلطاني.
اتفضلي.
سوري ممكن نطلع فوق ثانية
Yes,
واحدة؟
sure, yes.
في اللي هي حتة x squared plus y squared دي، هو احنا لو كانت مثلا minus اخد بقى negative common factor ولا اعمل ايه بالظبط ولا ما ينفعش
If the equation is x square minus y square equals 9,
مثلا
oh, okay, it's a cylinder as well, but it's not circular cylinder. Okay, I'll write what is you are talking about. Question. X square minus y square equals 9. Okay, this is a cylinder because there is no z. But which type of cylinder? What is the base of this cylinder? It is the curve x square minus y square equals 9, which is a hyperbola. This is a cylinder in the z direction, means z is its axis. The z axis is the axis of this cylinder, but the base is not circular anymore. This sign makes it no cylinder, no circular. It's a hyperbola. The base is not a circle anymore. What it is? What is it? It is a hyperbola, or the hyperbola. This is the hyperbola. How to draw the hyperbola? It's disconnected curve of two branches. Have you remembered it? Okay, this is the curve of the hyperbola. Two branches like this. Got it, Catherine?
تمام. thank you doctor.
Okay, so in 3D, this will be repeated, and the z-axis in 3D.
دكتور
Please, in 3D, we have this.
حضرتك سامعني ولا لا؟
Yes, Mahmoud.
ممكن نكتب الايكويشن بتاعت الهايبربولا بس
Okay.
عشان ساعات بيبقى فيه x minus a و y minus b وكام.
Okay. The general, yes, sure. So what we have here, Catherine, this is xy in xy, yes. This is x, this is y. So this is one branch of the curve, the other will be inside. We have this will be repeated up. The same inside as well. So you have some surface of two sheets like this. Got it? Your question, Mahmoud, is the general equation of hyperbola.
تمام.
More general. Is x square over a square minus y square over b square equals 1. This way, or the other way, maybe the other way as well. By the way, if this is not x square plus y square equals 5, x square over 2 plus y square over 4, or this stuff, if this is divided by different numbers, you know here, x square over 1 plus y square over 2 or 2, 3, and any two other different numbers, so it's not circular, it's elliptical. So it's an ellipse. We have the same situation. So again, very similar to the hyperbola, but positive sign. Ellipse x square over a square plus y square over b square equals 1. This is the ellipse, or this way. This is better. Any question? Is it clear now? So what is the idea of cylindrical coordinates يا جماعة؟ هي ايه؟ Cylindrical coordinates simply r theta z will be, instead of rectangular coordinates x, y, and z. What is the transformation? The same transformation we have for polar. The same transformations for rectangular to polar, which is xy to r and theta in 2D. The important remarks is what will be the volume element? Notice that dv, which is dx, dy, dz, and it has many other forms, dz, dx, dy, or dz, dA simply. dA is dx, dy, will be, any of these will be what? R, dr, d theta, dz. This is the important transformation. R, dr, d theta instead of dx, dy. And dz is the same. And it can be put in the beginning, or r, dz, dr, d theta. Or in any other order. And the idea of reading the region is the same idea of reading the region in 3D. So let's have some simple example. Right? The equation of the cone z square equals x square plus y square in cylindrical coordinates. So who can help? Participation يا شباب.
هو يبقى نفس هو مش مدينا الانتجريشن المرة دي.
مفيش هنا integration هنا بس exercising your familiarity with the polar coordinates or cylindrical coordinates in 3D the polar coordinates in 2D will be named cylindrical coordinates in 3D, because to mention the Z, not to miss the Z coordinate.
We can start by Z equals square root of x squared plus y.
The other question, yes, will be this. This is the equation. Solution is very easy. In cylindrical coordinates, Z stays Z. What will be changed? X and Y. You can substitute for r cosine theta and r sine theta, or if you know the result, you can write r square instead of x square plus y square directly. You need to know that. So it's z square equals r square. That's it. Which is, it can be simplified to give plus or minus r. The second question is sketch the graph. He already mentioned it's a cylinder. It's what? The cone. It's a cone. We need to know this as well. This can be given in another form. Of this cone, z equals plus or minus root x square plus y square. We already got this in a previous sheet, exercise sheet. Z equals square root of x square plus y square. Don't be confused with the equation of the sphere, because if it is a sphere, they have to be the same sign, the same coefficient in the same side. Here we have x square plus y square, but z square is not with them in the same side. If you transfer it to the right, it will be negative z square. So it's not a sphere, it's a cone. The sketch of this is, we already have done this before. It's a vertical cone. How to understand it? It's very easy. You can think of z 0. So it's a point, x squared. When z is 0, you get the circle x squared plus y squared equals 0. The circle, which is a point circle at the origin. When you come above the sea level or above the ground, z equals 1, you get bigger circle, x squared plus y squared equals 1. So you get this circle. And so on. If you come to z equals 4, you come to a bigger circle, x squared equals y plus y squared equals 16, and so on. In between, you get bigger circles and so on. So you get this cone. This is the cone. This is the upper branch of the cone. Z equals plus square root of x squared plus y squared. We have another branch down this line, this circles, increasing circles up and down. If we are given only the positive sign, we draw or sketch the upper half of the cone. If we are given the negative sign, we draw only the lower part of the cone. If it's both, so we are given both this extended cone, this infinite cone, part of it up, part of it down, as you see. This is the situation. Any question? كاترين؟
أنا تمام يا دكتور thank you.
تمام. سما؟ محمود؟
تمام يا دكتور.
تمام.
تمام.
تفضل. This is very important surface, the surface of the cone, the surface of the cylinder. We have few surfaces we need to be familiar with. So we need to put them their graphs, their equations before us and practice and their cross sections and this stuff and integration over the solids formed by them. Another question: to change rectangular triple integral into cylindrical. Okay, I can give you another question here. To find the volume of this cone, say this cone from z equals 0 up to z equals h. This means this part. Let here, this is not the 4 or the 16. Let it be h, z equals h here. We need to find the volume of this cone. Who can help? How to find the volume? We can do it by double integral. We can do it now another way by triple integral. So the volume is triple integral of 1 dv. The v here, the element of volume dv over this region E is described by this solid from z equals 0 here from this point up to the plane z equals h. So what is the description here?
وانا مش عارف الصراحة. تبقى في يعني دي
ايوه يعني the idea is the difficulty is when you go for x and y and z you have to fix x and y first and go from the smallest z up to the biggest z. The smallest z here, the smallest z here will be here on this cone, on the surface of this cone. Here z equals this square root x square plus y square up to z equals h.
دكتور هو اللي فاتت
Yes.
كانت فوليوم برضو؟
اللي فاتت yes, let's think about it.
اللي هي كانت الاي باور.
Yes, I'll bring it again. Is it volume يا محمود? Any answer? سما؟ شهاب؟
المفروض yes it's volume.
The question of Mahmoud, is this a volume? It's a triple integral, for sure it's a triple integral. Does it represent a volume?
Yes.
ليه؟
هو عشان ال x square plus y square و dv برضه.
لا مين فاكر يا جماعة؟ This is a function to be integrated multiplied by dv. This gives a mass. This is not a volume because this is not a 1 يا محمود. This is not 1 يا شهاب. If this is 1, the integrand is 1, we get the volume. As the same way we get the area in 2D, in double integral. In double integral, if we integrate 1 dA, you get the area. If you integrate function of x or y dA, you get the volume. So what this triple integral represents, Mahmoud? This represents the mass. If this is the function, if this function represents density of lamina in xy, so we get its mass. If this density of the lamina, we get the mass of the lamina. Think of density times volume, we get mass.
بس احنا
Or
دكتور في 2
if
دي
this represents, again, one more application, if this represents the electric charge density in some region, or we get the total electric charge in this region. Okay, go on محمود.
هو احنا في 2 دي كنا بنحط فانكشنز ما بتبقاش 1 وكنا بنجيب اريا عادي.
لا, this idea is in single integral, another situation, another explanation. We mentioned this many times now. The first application of double integral to calculate the volume. If f of x y dA, if you integrate f of x y dA, you get the volume under the surface of f of x y. If you put f of x y equals 1, you get the area dA, the area of the region R. Okay? Again, in triple integral, معايا يا شهاب؟
ايوه ده لو هي مش 1 لو هي 1 تبقى فوليوم.
Now, if this integral function is 1, we get the volume of this solid cube. If this is not 1, it is not the volume, it's something higher. It's fourth dimensional quantity, which is not volume. It's volume times density, maybe mass or electric charge density. It may give you the total charge and this stuff, this application. Got it, Mahmoud?
تمام يا دكتور.
Okay. So here we are asked to find the volume of this cone. So let's read this solid carefully. How to read the region, yeah, Catherine?
هنread it from ثانية أنا مش هي مكتوبة from z equals 0 to z equals h مش هي دي region.
Okay. Yes, it's from z equals 0 up to z equals h, but he said the cone.
sorry اوكي تمام. فاحنا هنعمل انها كل half of the cone يعني البوزيتيف والنيجاتيف روت هنقراها
لا
كده.
انا عايز الكون اللي فوق بس، عايز الهاف اوف ذا كون، الابسايد داون كون اللي هو اللي فوق يعني.
سوري انا كنت فاكره انه عايز اوكي تمام.
من z equals 0 up to z equals h.
روت تمام.
فاحنا الايكويشن اوف ذيس كون هي البوزيتيف سكوير روت بتاع x سكوير بلس y سكوير لغايه فوق خالص هيطلع عند z equals h.
تمام.
وبعد كده نعمل البروجيكشن بتاع دوت على الاكس واي بلين. اتفضل، ومين يساعدني؟ Who can help؟
دكتور هو الصوت قطع بس.
طيب معلش يا محمد.
ما سمعتش حضرتك قلت ايه.
اوكي. help me محمود. طيب
تمام. هنرسم البروجيكشن على الاكس واي بلين، مش الاكس واي بلين على
تمام، نرسم البروجيكشن على الاكس واي بلين. هيطلع البروجيكشن بتاع السوليد ده اللي هو الكون هيطلع ايه؟ ايدنتيكال سيركل للابر سيركل اللي هي الكبيره اللي فوق دي. لما z equals h يبقى الايكويشن ايه؟ x square plus y square equals h square. Or simply لو عايز تحولها if you change it into polar it's r square equals h square or r equals h. So this is the region R on the xy plane. It's the whole disk R from 0 to h. يبقى الفوليوم هو ايه هنا اهو يا جماعه. Very important, this one is very important. If you understand it, you understand a lot. ايه دي؟ دي بقى نكتبها ازاي؟ dz,
dz dA.
dA, this is 1 dz dA, and z varies from
0 to h.
لا z مش من 0، الزد من هنا من على الكون، ما تبدأيش من تحت خالص. لو عملتي كده you are doing a rectangular box. The same problem with doing a rectangular region in 2D. So this is not rectangular box, this is not a cuboid. So we have to go from general point. The general point here is on this cone. On this cone, what is the equation? Z equals 0 is the lowest point of the cone, the vertex of the cone. We need to go from the general point on the cone. The general point on the cone is this equation. Okay, I explain it again. If you are going from this surface, z equals f of x, y, up to this surface, z equals g of x, y. And you know a point here, and you know a point here. Don't go from this point to this point. Go from the general point, fix x and y, and go from the lowest surface to the upper surface. The smallest surface, smallest z, up to the highest z.
Okay.
So z equals square root x squared plus y squared. This is the equation of the upper cone, upper part of the cone, up to z equals h on this plane. Here, in the upper surface is horizontal, so its equation is easy. It's z equals h. Then what? Then the integral over r. Go on, continue, Sama.
هتبقى لو انت اللوبل انتجرال over region R.
Yes.
وبعد كده h minus square root
Yes.
x squared.
So it's z, substitute to get, yes, exactly, x squared plus y squared dA. The triple integral is gone. We are facing the double integral as usual. You can put it dx dy, you can put it dy dx, or better to put it what? This is your question before, Shahab. How to integrate this? We can do it, but easier to transform it into polar. Or, I mean, transform this dA into r dr d theta. Or originally, from the beginning, you can change this dv into what? dz, dx,
dz,
dy, or dz, yes, r dr d theta. Yes, we will do it now. Now go to polar. Or cylindrical, yeah. In 3D, we call it cylindrical. So go on, Sama.
about h minus r dr d theta.
Yes, this is r, exactly. Then
r dr d theta.
Instead of dA, it's r dr d theta. What is r? Yes, you need to read this region. This is the polar.
R from 0 to h.
Yes, not h. This is the r. Here we are here now in this region. We are in the region of the disk. We need to scan this disk. So what to do? Again and again, I write it in details for the PDFs I sent to you. Fix theta. Read r, vary r. Read it from 0 to the equation of r here. Yes, r equals h. You are right. Sorry, Sama? Here
Yes.
r is h, exactly. Then what? This is theta. Move the theta from 0 to 2 pi. Exactly. R from 0 to h. theta from 0 to 2 pi. Can we separate it into product of two integrals as the previous example?
No,
No, because this one,
inseparable.
it is. But we need to partition the integral first.
دكتور انا ما فهمتش اخر حته ايه.
Which one, محمود?
هو ليه الار من 0 ل h مش المفروض ار من 0 للجنرال بوينت؟
اوكي
السيركل بتكبر وبتكبر.
Okay. This is the solid. محمود معايا? This is the solid we are speaking about. This is the upper part of the cone. Okay? This is the cone.
تمام.
Yes? we عملنا اسمها ايه؟ vertical strip from the smallest z, the general point you mentioned, up to the upper point. This is the integral with respect to z first. Yes? The second part is to do the double integral over the region R in 2D. How to do the region R in 2D? You get the projection of this solid onto xy. What will be the projection on 2D يا محمود؟
انا مش فاهم احنا ليه خدنا اللي هي السيركل اللي فوق اللي هي z equal h دي.
طيب z equals h is the height of the cone he mentioned. He asked me to find the volume up to z equals h. Means the cone with height h from 0 to h. When we come to the projection of this solid onto xy plane, what you get, محمود؟
اللي تحت دي اللي احنا رسمناها.
كويس. What is its radius? It is similar to which circle? The bigger one, the highest one. So this is the case. The projection of this solid, while there are very small tiny circles here, but the projection of the whole solid, this is the ice cream cone, its projection on the xy plane will be, this is the xy plane, the projection of this solid on the xy plane will be the biggest circle you have. So you get this circle. You get this circle of radius h, as Sama mentioned, from 0 to h, exactly. Got it, Mahmoud? This is very important point. We integrate over the region, the shade of the region on the xy plane, or on the yz plane if you begin by x and so on. So here we usually do that first and then come to xy plane. Got it?
تمام.
Come on. The circle is R equals h. So go on, Sama.
We'll expand the bracket and ندخلها تبقى RH minus R squared.
Okay. H is constant, by the way. H, R, dr, d theta, minus another integral, R square, dr, d theta. We could theta, yes. Let's do it this way, because d theta is can be done separately, because d theta, there is no theta here. D theta, this is d theta, Sama. This is theta, no other theta. This is all can be treated as a function of R. So no need to multiply, no need. We can separate them. It's a separable. Okay?
Okay.
So let's do it this way. So it's d theta from theta equals 0 up to 2 pi, which gives 2 pi, and then integrate, multiply first.
Well, RH minus R
HR
squared.
minus R squared. Gr from R equals 0 up to h. The rest is easy. This is 2 pi times here.
HR squared over 2 minus
Yes.
R power
Yes,
3 over
so
3.
it's h over 2 R squared minus 1/3 R cube from 0 to h. So what we do, this begin by plugging the upper bound, then subtract the lower bound. So it's 2 pi times plug in the h instead of r. So we get h over 2 times h squared minus 1/3 h cube. Then this is plug in the h, then 0 gives 0, because r squared and r cube will be 0. At the end we get, this is 2 pi here h cube over 2 minus h cube over 3. 2 pi times this, we can have common denominator, which is 6, multiply here by 3, and down by 3 to get 6. Here we multiply up and down by 2 to get 6. 2 times 3 is 6. Why we do that? Because to have common denominator, so we can add and subtract. So it's 2 pi times 3h cube minus 2h cube over 6. This can be simplified to give what? This 2 cancel with this 6 and give
pi over 3 h bar
3.
3.
Yes, this is h cube over 3, which is 1/3 h cube. Do you know the formula for the volume of the cube, the cone? Check. Why is this form? You know the formula of the cube, the cone?
1 over 3 pi r squared h.
Yes, bravo. This is R, this is H. Check volume of cone equals 1/3. It's third the volume of the cylinder, so it's 1/3 r square h, pi r square h. Where is pi? Yes, there is pi. I missed pi. Pi. Yes. Pi r square, because it's the area of the circle, and times the height. Why we got it this form? Have you noticed, Mahmoud?
عشان R ب 1
لا الار هنا بايه؟ بص كويس. R equals H. Yes, هو قال لي لغايه up to the height H. الهايت H وكمان الهايت H at the height H we have a circle of radius H. So it's a special case. So when R is H, we get volume 1/3 pi H square times H, which is what we get, 3 pi H cube. Done. Checks. يعني مظبوط. What we get is right. Another example. Asking me to change the description of the region or the solid in space from rectangular coordinates or Cartesian x, y into cylindrical coordinates, right? This integral z dv is a triple integral in cylindrical coordinates. If q, given the q, the description of the solid in space is all points x, y, and z satisfying x squared plus y squared less than or equal to z less than or equal to square root 18 minus x squared minus y squared. any idea of the graph of this solid or the surfaces bounding this solid? Yes, we have some idea from the previous example. We now familiar with the equation of the part of this cone, the upper part of this cone. Z equals square root of x squared plus y squared is the upper semicone. So this part we know this part. This is half of the cone, and the other one. Who can help? Participation.
دي سفير تقريبا.
Yes. How to prove that, ya Mahmoud? This one. This is the upper half of the cone. Yes. Mahmoud says this is a sphere.
نعمل زد ايكوال وبعدين سكوير روت سكوير الاثنين.
Yes. This is semi upper cone. The upper half of cone. Which cone? Z square equals x square plus y square. Z equals plus or minus root x square plus y square. Z equals plus or minus r. The one he's speaking about is this one, only this one, the positive side. So
طب انا اعرف منين اللي هي الابر بارت؟ هو يقول يعني ولا ايه؟
yes, he already said this is positive square root. This one, Mahmoud.
تمام ماشي.
Yes, once more, if you are given y equals Mahmoud 4 minus x square, this is in function of one variable. This is what?
upper semicircle.
Yes, upper semicircle. Why you know upper semicircle? Because it is a positive square root. If x equals root minus square root 9 minus y square, so again, what you have here, the left semicircle. Got it? Yes. If this is negative, if here is negative, so it's a lower semicircle. If this is positive, it's a right semicircle. So we need to be familiar with these graphs. Again, so we have what we have, Catherine, here. We have cone, the same cone, the very important cone. Circular cone. Yes. Its equation is z equals square root x squared plus y squared. In polar, it's z equals r. Very easy. This is why we have this topic today, to have some complicated equations in x and some complicated equations in x and y are easy to deal with in cylindrical. So are dealing with this infinite semi-cylinder, the positive side. The other one, Mahmoud said, expected to be sphere. Yes, your expectation is right. So let's prove z square equals 18 minus x square minus y square. I squared both sides and take this equal sign instead of the inequality to get the bound. So this x square plus y square plus z square equals 18. Yes, sphere. يبقى احنا هنا hemisphere. In fact, hemisphere. Which hemisphere, ya Mahmoud? Upper or lower?
Upper hemisphere.
Yes, because of the positive sign. Hemisphere. I'm sure now it's a sphere. Yes, we take this part of it. Yes, sphere. And we have the upper part of it. Half of it. So what is this solid look like? The sphere. is center 0, 0. So we have something here like this. So we are speaking about what? This solid between, فين السوليد يا كاترين؟ فين يا سما؟ He says Z is between. Z is bigger than this cone. This is the equation of the cone. Z is up over this cone and lower than this hemisphere. We don't need all of this sphere, by the way. We need only this part of it. So where is the solid speaking about, or the region he is speaking about?
البوزيتيف ده اللي هو الابسايد داون كون ولا؟
Yes, أكبر Z bigger than this cone and less than this sphere. So where is this region? This is the common part between. Okay, I'll omit this part. We don't need this. This is not included. Yes.
التريانجل اللي تحت اللي bounded by the sphere.
Yes, exactly. This is the thing. This is the thing. هي دي. This is the upside down part of the cone inside this sphere. These points are the points satisfying this inequality. Z here is bigger than the cone, the Z of the cone, because as you see, and less than the Z of the points on this sphere. So we can evaluate the volume of this part or make any integration of this part over this solid. And the situation will be like this. We will finish with this. So the integral will be Z was from where? Z was from من root x square plus y square، يعني من عند الكون up to Z عند السفير بالظبط كده، which is 18 minus x square minus y square. Then what يا محمود؟ دي A.
1.
This is R. The double integral will be, this is F R theta Z d R d R d theta d Z.
دكتور طب ما دي فوليوم اهو ما حطيناش 1.
إيه مين قال فوليوم؟ مين قال فوليوم؟ حد قال لك احسب فوليوم هنا؟ انت بتتخيل. اهو نفس الكلام اللي قلته تاني يا محمود. Again, this is triple integral of some integrand function. If this function is 1, so we are computing the volume of this solid. If this f is not 1, it is not the volume. It is a triple integral over this region V. Okay? We are not given f anyway. We are not going to integrate. The question is all about the geometry and reading the region. Okay? He asked me to put it into cylindrical. So how to change this into cylindrical? Shihab? So this is R, yes?
Sorry, I was talking on mute. دي هتبقى R والتانية هتبقى.
Again, we will change this into root.
المفروض polar بقى صح؟
Yes, root 18 minus R square. So Z depends on R.
Okay.
So we do the integral with Z first. So we put the z inside.
بس هو مش هو عشان نحطها r squared لازم x squared plus y squared يعني هنا
Yes, it is. It is. It is r squared. It is x squared plus y squared. I took the negative sign out and put it like this. Get it?
طب ما كده هتبقى 18
أهي.
plus r squared مش في
Yes, minus يا سما. Minus x squared minus y squared.
ماشي وفي
So it's
minus بره
18 minus r squared.
اوكي
Okay. So this is r dz dr d theta because we integrate with respect to z first because I go from as a type 1 region or solid from the smallest z first up to the highest z from the surface of the cone upside down cone up to the upper hemisphere of this sphere. Then what? Read the region A. What is the region A, Mahmoud? This is your question few minutes ago. How to do the region? How to do this part?
عشان نجيب
The shade. What is the region? Will be the shade of this region solid over the XY plane. From here, the shade of this solid on the XY plane will be again another circle. صح؟ How to get its radius يا محمود؟
هي ازاي ال projection على x y plane هيبقى circle.
Okay. Do you see the solid? We are speaking about the region of integration between the cone and the hemisphere.
تمام.
The intersection of this cone with this hemisphere is what? This is a circular cone cutting this hemisphere. Their intersection will be this circle. There is a plane here which will cut the hemisphere in a circle. We can find the points of intersection anyway. We can find the points of intersection and solve it. You will see the circle. It's easy. Okay, let's do it. The cone is z equals root x squared plus y squared. The sphere is root 18 minus x squared minus y squared. Let's equate them to find the points of intersection, what they satisfy. Are you with me, Mahmoud?
تمام.
So equate them and remove the square roots to get x squared plus y squared equals 18 minus x squared minus y squared. What we'll get again? 2x squared plus 2y squared equals 18. Divide by 2 to get x squared plus y squared equals 9. That's it, circle. So the points of intersection of the cone with the sphere, half cone, half sphere, they satisfy circle. So this is the proof that analytically that they intersect in a circle.
يعني أنا مش لازم أعرفها geometrically كده عشان هي.
Okay, you need to solve the equations you need to solve them anyway because we need to find the equation of this shade, of this projection. We need to know the radius بتاعها 3. So we have 3 here, 3 here. So x squared plus y squared equals 9 or r equals 3. This is the region R of integration at the end of this triple integral. So we go here again, the same situation. I will not write it again. I'll put it directly r from 0 to 3 and theta from 0 to 2 pi because we have the whole disk. And the inner integral is from z equals r up to z equals root 18 minus r squared. The same function r theta z. dz r dz dr d theta. This is what we are asked to find, to write the integral in polar or in cylindrical. We cannot perform the integral because the function is not given. Any question?
دكتور ممكن نجيب الشيب تاني كده؟
Yes, sure.
هي الزد كان من ار سكوير روت اكس سكوير بلس واي سكوير صح؟
Yes, this is the given. It's given this way. The solid or the region in 3D is given in set theoretic notation. يعني it's written in this way. The points x, y, z satisfying these inequalities, these conditions. Z from the cone up to the sphere. So it's the upside down triangle here,